Here we're going to talk about composite functions. Now, composite functions here we have f of g of x, and it's written as f parentheses g of x. And so if we have our two functions, f of x labeled as x squared and g of x labeled as x minus 3, if we want to find the composite function, that is f of g of x, we're basically asking what was written up here, f of g of x. And what we will do is substitute in g of x in for this part of the equation, which is known up here to be x minus 3, okay? And for our f of x into this x. Now our f of x is the x squared, and so when we plug that in, we would get, okay, f of x is this quantity squared. The x that we're using is the equation that is g of x, which is x minus 3, okay? And that would be our equation. Our answer for f of g of x is x minus 3 squared. Now, of course, you could FOIL that out and stuff, but that's not what we're working on here. So if I wanted to do g of f, which you can do, g of f, okay, that is g of f of x, okay? Well, f of x here we know to be x squared. So we would take g of x squared, which is our f of x, like so. And then we will plug that x squared into our function g of x. G of x being our quantity, our variable, it's right here when you plugged in, minus 3. And that variable coming in is that x squared. I'm very big on putting parentheses around things that you're substituting in. It really helps solidify your equation. It really helps making sure that you don't make a mistake along the way. For this composite function in this example, we're going to be given new parts where f of x is equal to square root of x and g of x is equal to the square root of 2 minus x. This one's going to be a little tricky because we have multiple square roots here and we have to make sure we have everything in line. For this example, let's deal with g of f of x. Well, g of x, okay, we're going to keep our form. Eventually you get faster at this, you won't have to keep writing it like I'm doing here, but basically we're doing g of the square root of x. Now we know, little note here, the domain to keep in mind is that the square root of x has to be greater than or equal to 0, making x greater than or equal to 0. That's something we want to note here as we go along. Well, g of x here, okay, g of square root of x. Well, g of x we know to be the square root of 2 minus x. And we're plugging in here that square root of x. And fantastic. So now we have our composite function right here, okay? We have our composite function. But now we need to find the domain of this function. Well, we know that x has to be greater than or equal to 0 if it's in the square root here. So let's apply that here to this part of the domain. Well, we have 2 minus the square root of x. That has to be greater than or equal to 0. All right, so the second part of our domain here. Well, we can see that if I subtract the 2 to both sides, I'm left with a negative square root of x is greater than or equal to negative 2. Okay, well, if I multiply both sides by a negative 1, I have the square root of x is less than or equal to a positive 2. And then if I square both sides, I have x is less than or equal to 4. So now we have a restricted domain that x has to be greater than 0, right? Greater than or equal to 0, because we know that in any square root function here, that was going on the inside of square root that came from in this part here would fail, has to be greater than or equal to 0. And then the highest value here is 4. So our domain for this function is between 0 and 4. And again, remembering these brackets mean that you can include 0 and 4 as part of your domain. If it was parentheses, you could not include it. I hope you find this video informative. Thank you for watching our YouTube channel. If you like the videos we provided, you can subscribe down below. You also can follow us on Facebook, Instagram, and Twitter. Have a good day.